Otskare everyone, welcome back. Today I'm gonna go through making a application in Chumbucket. I know I took a detour last video, but we're gonna be doing something pretty cool, pretty fun, using Chumbucket as the base. It's not very complicated, but it will give everyone a bit of a chance to jump in to the boilerplate and think about improvements or things that they like and dislike about it. So, what are we doing? What are we building uh, this video? We're going to be dipping our toe into steganography. So, in this video, we're going to go through making an app with the cryptology system steganography. If you're not familiar with steganography, I'll just do a brief explanation for you. It is the practice of concealing a file, message, or image or video inside another file, message, image, or video. Comes from Greek, as everything does, and it means to cover or conceal in Greek. And there's a little example on the side here which shows in the first image they've very basically changed the pixel values so it almost identical, almost invisible to the naked eye. But when you split out the color values, you can see that there's a 4, there's a 5, and there's a 3. We're going to use a similar technique. I'm not going to go through the actual library and algorithm because I mean that might be interesting for another video, but in this video we're going to just basically use the techniques to store information in kind of a silly and dumb way, but as an introduction to the system. I'm sure everyone is kind of familiar with data URLs. There's this beautiful website which lets you generate these directly from an image. So you can see I have this cat image here, and I've just created this data URI here. And there's a lot of information which is not necessary inside this image, inside this data. And when you can start manipulating the parts of this which won't actually affect the image, that is when you can start storing things inside these images. And these images are completely undetectable by, well, not completely undetectable. Of course, if someone expects it to be there, but these images appear normal when you share them on social media, in downloads, or anything. So it's kind of very interesting. Like, if you think of Facebook, you could, like, someone's entire page could be images stored with data stored inside those images. They could, you could have a photo of your grandma and then you convert it and it's really the video URL to Rickroll. You could do that because that's steganography. So less rambling and going to random links, I'm going to boot up the code. We can have a look-see. Okay, before we jump into the code, I just wanted to show you what we're building. This is the final application. Did a little bit of design myself, a little grunge look. You can actually go here, cover.stagfoo.com. /player is the player, and just did a very basic hyperlink where you can actually create these steganography images. So, just to give you a little example, I've got the player here, and I'm going to grab one of the example images I've downloaded here. I'm gonna stop that so I don't get copyright claimed. Here's my design in Figma, but that is the basis of the app that we're going to be building. You can generate these images and download them like so. we paste in a YouTube link, it stores that YouTube link inside the image, and then that image can be shared, dragged, and dropped into the player to play it again. Alrighty, so let's jump into the code. Okay, so we're inside the code here. There's not much different here, not really anything different. I put in a debug function that I didn't remove, but I mean it's good for everyone else to be able to read the debugs. Just pass that function into here, and the S, it returns as the state. I removed hydrate and dehydrate for this app, just to avoid any sort of errors with the old state when I switch between the pages. If I make it into a full app, I'll put it back. But for now, we're checking it out. We're gonna go over to the UI because it'll be real quick. Now, we saw in the live version that we have the basic wrapper. Doesn't really change much. Sorry, we're gonna go to the actual view. So in this section here, this is the home page. We've got our big title, which you can see inside the website, and then we've got the wrapper around the image handler. And that, what we saw before, was a layering of the 4 images that I'm using to compose the CD. We jump over to the web here, and we scroll to the top. This image is composed of the frame, plastic, and then there's an area for when a URL is added. So if I add test, it adds that CD to show that a URL is present. And if you add an image, we add this cute little cat, we can see that image there. And then once this image has been generated here, once this HTML has been generated, I export this HTML to a canvas and then download the canvas as a file. So we're going to go back to the code here. So in the router page here, we've got the in the image handler, we have the state.image doesn't equal null, otherwise show, and then we've got the cat image that we just saw. Oh, I did a little overlay to make it pop more for the plastic, so there's actually 2 images there on that personal cover, just because it was a bit washed out. And then here we have the show nothing or the asset CD if the state.youtube doesn't exist. On this note, we'll jump to the state, just to the store. So we have a little understanding. We've just got basic YouTube, track, the track cover, and an image. So the YouTube is the URL to add to the image, and the image is the image, which was our cat, and this was our test, and the track cover is for the player, and the track is the YouTube from inside the image, the steganography value that we've decrypted. Okay, so that's this little thing here. We got a little that's the player, right? Here we got so that's how I compiled that image up there. And inside the file here, we've got the general capture with an on change, which sends the event to our action cover image. Pretty straightforward, an on change for putting in an image. And then we can see those are the 4 images I just placed there. They're just sample steganography images that you can download and test with. We have the action bound to the button, this button here, save your music picture, and that will take the information out of the state and generate the new steganography encrypted image. So I think this is the most interesting function that we should go have a look at. So right off the bat, I've got this canvas ID for the steganography. The library I'm using, I've included here, cryptostego.min.js, mainly because it's not on npm. I just included it as a standalone library just to make it a bit easier, and it's called inside the header of the application. So here I've got my steg.can, which is the canvas. The import I have here is a DOM to image, which is what I'm using to inside this create cover to convert the HTML here into a data URL. Once it's a data URL, I can store it inside a canvas. The way that the steganography library works is it takes information from a canvas. So there's a bit of canvas hopping, but it's only temporary, and all the canvases are cleaned up. So we create an image from the canvas, which takes the data URI, sticks it inside the canvas. The canvas is 480, and the canvas ID is stated above. And the image we want to write to that canvas is the state.youtube mentioned before, and this is the encryption key cover-app. So you can set this to anything. You can also set it to nothing if you don't have anything that you really need. But that's the general. You can add this to to be actually important if you wanted to make it a secret value. There's a timeout to let the canvas load. You can do this. You can do this on a callback as well. I haven't had any issues, even with extremely large images, like 2 megabytes. I think the 1000 is fine. It's just converting it and then chucking it in all locally. So I don't think it's a big deal. But yeah, we have the download canvas, which we pass in. Let's have a look at that function down here. It creates an A element. It puts the link, the download is the file name, and then the href is just the data URI from the canvas. And this is a really easy way to download canvas data as an image for future if you want to snippet that. But the main work is done here, where it creates that. It takes the DOM into a PNG. It then saves that to the canvas using steganography, which saves the image by doing that pixel shifting technique that I mentioned, where you can just change the elements, the values slightly, and it means that the image will store that information. You might be able to extract it, with a bit of work. I don't think it's super secure, but I mean the main security for this is the fact that nobody knows it's there. It's invisible, right? So I think that's one of the main keys with this sort of cryptology technique. But I mean, I'm just using it for fun, so doesn't matter. You can use it for fun too. There's a really nice game engine actually called Pico 8. Yeah, Pico 8. And the way it uses this technique is every game you build inside this I think it's a fantasy computer, so it's not actually a game engine. It's like a fake computer. But it will save all the images using steganography, and then you can share them as actual images, just like the CDs that I've created inside Cover. You can share these on social media and whenever or wherever you want. Your music playlist can be just a bunch of PNGs, or you can have a Twitter account which just shares out PNGs with secret songs inside them. Pretty silly, but pretty fun. So we'll go back to the main function which runs it, and then the actual message to the canvas is run by this this global library that I've set up here. You can go to the effort of importing and stuff, but for this example, I just took it straight from window because I know it's going to be there, and pass it in that very basic image. So we go down, and we might just jump back to the web, and we're going to talk about that player here. So this player again uses layers on the UI. We've got the 4 example images, and then we've got the player handler. Inside the player handler, it has the exact same system to set up to layer up that CD image, but it has a bit of extra to make the disk spin using the CSS animations. Just simply place it on there, set the spin to be unlimited, yeah. Really basic animation. Spin goes from 0 degrees, 360 degrees, and then when I apply it infinitely, so it spins forever. And the spin speed is the duration, right? So we've got our image spinning, the background image of the track cover taken from the uploaded image. The empty case is an empty case, and we've got the here which takes the actual image you upload and then extracts the information. The way that I did the spinning of this track image is I actually just crop it. So I'm just going to go back to the web, and so the image is added. I've just muted it so then I don't get any copyright claims. But yeah, you can see that the image of the CD is now rotating, and this image here, instead of extracting it out of the CD, I've just done a very basic crop because I know that this is going to be 480 by 480, and I know this square is going to be a certain size. So I've just cropped this, put in the curves again. It sits on top perfectly. It looks great, and then the image just does its little spin. So I didn't want to be technical, try and extract it or do anything like that. Just a simple crop, and it looks nice. So that's this track cover here, and the cropping is done using the class track cover. So we're going to go back to the actions so we can understand this player. How does the player work? So when you play a track, it takes the file out of the image, which is on the onChange event. It updates the update track with that data image. It creates a canvas using that data image, which it then uses the library and extracts out that information. I've included the encryption key I mentioned before, cover app, and this is just the canvas ID player can. Once it has the information, which is a YouTube link, it will store that inside the state, and that information will then be picked up by the UI inside this beautiful 1 pixel by 1 pixel iframe. And it's that simple. So it just extracts out that ID. We can probably see inside our console. Go to the web. We can see inside our console we have that YouTube ID here and the information here. YouTube track ID, data URI of the image, and I think that's about it. Like I can polish it up, make it a bit nicer. It's not a very useful app, but introducing people to the world of stenography is very interesting, because this technique can be used for anyone's application. I highly recommend looking into it. It will allow you to create your own encryption files, basically your own file formats. If you have a game, you want to store something, you can store it inside inside images to make it look beautiful. You can store inside MP3s. So then you could do the reverse of this, have an MP3 and store the images inside it that way, which probably more practical, but I thought making beautiful images was a lot more fun, so I did it this way. And you know there's gonna be a bunch of like indie Tumblr people which are like, oh yeah, I only listen to PNGs now. So you know, what are they gonna do? I need to make this application for them. Yeah, I think that's about it. If you have any questions, this code, the link to this application and the code will be inside the description. If you're interested, I can also go through the design, building it in Figma, because it was a lot of fun finding these royalty-free disk images and stuff. But yeah, let me know your thoughts. If you have any questions in the comments. And yeah, Janewani, as we always say, and have a good weekend.